This question has a very similar setup to the questions in forces, where you can use vector addition to solve for the unknown force. But in this case, you have very little information given to you. You have only the downwards force, which is 0.40 Newton acting on the pendulum bob. Now, if this is the case, then we can have two ways of solving it. In the last chapter, you have used vector addition to add up all the forces. You are actually using Newton's second law because the object is not moving, it's at equilibrium. The sum of all the forces, the resultant force itself, is 0. So you're using second law. Now, in this case, I will show you how to use principle of moments to solve this question. So, in fact, in part A, the question tells you to use moments to solve for this question. So we let the pivot point be P, and there are two remaining forces acting on the object. So on the force, for the force F, it will want to make the whole object rotate in a clockwise manner about the pivot point P, and the downward weights of the bob will want to make the whole object rotate in the anti-clockwise moments. So the values are there for you to check. If you need help in identifying the correct perpendicular distance, please refer to an earlier video in that for the MCQ question. And also remember to convert the values of length to meters to use SI units to prevent careless mistakes later on in your workings. With this done, what remains to be done again is to plug everything into the POM equation, and with that we can get force F to be 0.30 newtons. Now in part B, there's this tension force in the string, and you are to explain why this force have no effects on principle of moments. And that is because if I draw out the tension force in the string using the yellow vector, it passes right through the pivots. And when a force passes right through the pivot, the perpendicular distance of that force away from the pivot itself is 0. This means that this force, in this case the tension force, does not create any turning effects about the pivot point. It doesn't make the whole object rotate in any way. So it doesn't affect your calculations in part A when you're using principle of moments.